The air around you has weight and pressure against everything it touches. The pressure is called atmospheric pressure or air pressure. So, if there were less air or no air, like in a vacuum, the area would have very low pressure. It would be extremely unstable and attract or pull air from its surroundings to return to normal air pressure. If the same area had more air than usual, it would form a high pressure region and would mean that air needs to be pushed out to neutralize the imbalance. Atmospheric pressure is an indicator of weather. A low pressure system that moves into an area usually leads to cloudiness, wind, and precipitation. High pressure systems usually lead to fair, calm weather. So, how do we get high pressure and low pressure areas in our atmosphere? Hot air rises and creates low pressure, while cool air lowers, creating high pressure. Air is pushed out of high pressure systems as it hits the surface and spreads out, while low pressure systems tend to suck in air at the surface and pile it up into clouds and storms. Why are we learning about air pressure? To understand how air moves. Air usually travels in the form of an air mass. An air mass is a large volume of air in the atmosphere that is uniform in temperature and moisture. Air masses can extend thousands of kilometers across the surface of the Earth. Air masses, called source regions, form over large surfaces with uniform temperatures and humidity. Low wind speed lets air remain stationary long enough to take on the features of the source region, such as heat or cold. When wind moves air masses, they carry their weather conditions, heat or cold, dry or moist, from the source region to a new region. When the air mass reaches a new region, it might clash with another air mass with a different temperature and humidity. This clashing of air masses can sometimes create a severe storm. We can identify air masses according to where they form over the Earth. There are 4 categories of air masses: Arctic, tropical, polar, and equatorial. Arctic air masses form in the Arctic region and are very cold. Tropical air masses form in low latitude areas and are moderately warm. Polar air masses take shape in high latitude regions and are cold. Equatorial air masses develop near the equator and are warm. Easy? Air masses are also identified based on whether they form over land or water. Maritime air masses form over the water and are humid. Continental air masses form over the land and are dry. Therefore, an air mass that develops over northern Canada is called a continental polar air mass, and it's cold and dry. One that forms over the Indian Ocean is called a maritime tropical air mass. It's warm and humid. Can you find out which air mass has the most effect on your weather? When an air mass moves, it has a leading edge called a front. Warm fronts mark the leading edge of a mass of warm air. When it encounters a colder area, the warm air starts to flow over the colder area and cools. When it reaches the condensation point, clouds and rain form. Warm fronts create a gradual change in weather, usually longer lasting. Cold fronts are associated with low pressure systems. They bully warmer air out of the way, causing a sudden and intense instability in the atmosphere. If the temperature difference is big enough, clouds form rapidly along the front, often growing into towering thunderstorm clouds, bringing torrential rain. After a cold front passes, the temperature can drop almost 40 degrees in just a few hours, with a drop in humidity as well. So, you must be more cautious when you hear a cold front approaching than a warm one. If you see a cold front on a weather map and don't know if it's coming towards you, a cold front usually moves east or south. Now we know what air pressure is and how it affects the weather. We understand that air exists and moves in large volumes as an air mass, and air masses have a leading edge called a front. From this, we can also derive that when two very different air masses clash, they can lead to unpredictable weather. Have you found out what air mass affects your weather? I'd recommend you do this before we move to the next lesson, where we further understand stable and unstable weather systems.